This experiment shocked everyone. Watch this machine carefully, something crazy will happen. At exactly midnight on March 1, 2026, long-range bombers lifted off from runways thousands of kilometers away from their targets. Not fighters. Not drones. But aircraft designed in the Cold War. The B-1B Lancer and B-52H Stratofortress. And on paper, that should not make sense. One of these bombers first flew in 1952. The other in 1974. Yet both were deployed together in what the U.S. military called Operation Epic Fury. So the engineering question is simple. How can aircraft designed decades ago still perform some of the most complex strike missions in modern warfare? Because when you analyze it from first principles, physics, radar detection, and logistics, the answer isn't nostalgia. Modern warfare has a brutal constraint. Distance. Launching a strike aircraft from a nearby base is risky. Forward bases are vulnerable to missiles, drones, and sabotage. So instead, militaries rely on something called strategic reach. The ability to strike targets thousands of kilometers away without relocating forces. Visual, graph comparing combat radius of fighters versus bombers. For example, a modern fighter like an F-16 may have a combat radius of roughly 550 kilometers. But a B-52H can fly over 14,000 kilometers with aerial refueling. That changes the entire equation. Instead of moving bases closer to conflict zones, you move the target within range of the aircraft. Wait till the end, the result is crazy. Aircraft design is always trapped by a brutal engineering triangle. Payload, range, fuel efficiency. Increase one, and the others suffer. Bombers solve this problem with size. Visual, scale comparison, fighter jet versus B-52 wingspan. The B-52H has a wingspan of 56 meters. That massive wing does two critical things. Reduces wing loading. Improves aerodynamic efficiency at high altitude. Meaning it can carry 32 tons of weapons while still flying across continents. But this comes with a cost. It is not stealthy. Radar detection depends largely on radar cross-section, or RCS. A large aircraft with straight surfaces reflects radar energy like a mirror. That's exactly what the B-52 does. So engineers tried a different approach with the B-1B Lancer. Visual, B-1B wings sweeping backward in animation. The B-1B introduced variable sweep wings. At low speeds, the wings extend outward for lift. At high speeds, they sweep back to reduce drag and radar reflections. This allows the bomber to fly near Mach 1 at low altitude. Why low altitude? Because radar systems struggle with something called ground clutter. Visual, radar screen showing clutter interference. By flying close to terrain, the bomber hides in radar noise. It's not stealth in the modern sense. But it dramatically reduces detection range. Subscribe to the channel, because the next video will explain why one bomber designed in the Cold War may still dominate the skies in 2050. Here's where the engineering becomes even more interesting. Modern bombers rarely fly directly over targets anymore. Instead, they launch standoff weapons. These include cruise missiles capable of flying hundreds or even thousands of kilometers. Visual, cruise missile terrain following animation. These missiles use inertial navigation systems, GPS guidance, terrain following radar, allowing them to fly just 50 meters above the ground, which drastically reduces radar detection. So the bomber itself stays far away, while the missiles do the dangerous part. Visual, aerial refueling tanker connecting to bomber. But none of this works without an enormous logistics system. A long-range strike mission requires aerial refueling tankers, satellite navigation, command and control aircraft, electronic warfare support. In some operations, one bomber strike may involve 20 supporting aircraft. Visual, Air Operation Network Diagram. Which means the real engineering challenge isn't just the bomber. It's the entire system around it. A flying logistics network spanning continents. These bombers are powerful, but they are far from perfect. Visual, cost comparison graphic. Operating a B-52H costs tens of thousands of dollars per hour. The B-1B is even more expensive to maintain due to its complex swing-wing system. And neither aircraft is truly stealthy compared to modern bombers. Which is why the US is developing the next generation B-21 Raider. But that aircraft costs hundreds of millions per unit. So why were these bombers used in Operation Epic Fury? Because despite their age, they solve a problem that still hasn't changed. Physics rewards size, fuel capacity, and range. And no drone or fighter yet matches the combination of massive payload, global reach, standoff strike capability that bombers provide. The real lesson isn't that these aircraft are old. It's that good engineering lasts longer than expected. Because while technology evolves, the laws of physics do not. And sometimes the most powerful weapon in modern warfare isn't a new invention. Loop trick, did you see that? Let's watch again. It's a 70-year-old aircraft engineered well enough to outlive its own era. Subscribe to the channel, because the next video will explain why one bomber designed in the Cold War may still dominate the skies in 2050.